Okay. Good day. My name is Ahmed Niazmuratov. I'm freshman at Textile Light Industry University. Today I'm going to talk about basic types of deformation processes and its temperature. Metal forming is a large group of manufacturing processes in which plastic deformation is used to change the shape of metal workpieces. The tool which is used in metal forming is usually called a die, which applies to threads that exceed the yield strength of the metal. The metal takes a shape determined by the geometry of the die. Material properties and metal forming. So, we should know that in every metal forming processes, we need to have material properties. The first and desirable material properties are low yield strength and high ductility. These properties are affected by the temperature. Ductility increases and yield stress decreases when work temperature is raised. Other factors which should be shown on the process of the properties: strain rate and friction. Basic types of deformation processes. There are 4 basic types of deformation processes. They are for bulk deformation. They are rolling, forging, extrusion, wire and bar drawing. There are another types for sheet metal working. They are bending, deep drawing, cutting, and miscellaneous processes. Bulk deformation processes characterized by significant deformations and massive shape changes. Bulk, the word bulk refers to work parts which relatively low surface area to volume ratios. Starting work shapes included cylindrical billets and rectangular bars. Rolling process. In rolling process, there are 2 cylindrical billets, and the work undergo rolling process. The cylindrical billets forces the work, and the work just take the shape of the rolls. Next thing which we should know is the sheet metal working. In sheet metal working, forming and related operations performed on metal sheets, stripes, and coils. High surface area to volume ratio of starting metal, which distinguishes this from bulk deformation. Often called press working, because in sheet metal working, press performs these operations. Temperature plays a key role in metal forming. Any deformation operations can be accomplished with lower forces and power at elevated temperature. There are 3 types temperatures which range in metal forming. The first is cold working, second one is warm working, and the third one is hot working. So there are some advantages and disadvantages in terms of all of 3 temperature range in metal forming. The first is cold working. The cold working performed at a room temperature or slightly above. In cold working, many cold forming processes are important mass production operations, and minimum of or no machining usually required. These operations are near net shape or net shape processes. Second type of temperature is warm working. Warm working performed at temperature above the room temperature but below recrystallization temperature. Dividing line between cold working and warm working often expressed in terms of melting point. It's about 0.3 Tm, where Tm is melting point, absolute temperature for metals. Hot working, this is the last one for the temperatures. Hot working deformation at the temperature above the recrystallization temperature. Recrystallization temperature is about 1/2 of melting point and absolute scale. In practice, hot working usually performed somewhat above 0.5 recrystallization temperature. So, in metal working, in hot working process, metal continues to soften as the temperature increases above 0.5 temperature, and enhancing advantage of hot working above this level. So, thank you for your attention. This is all about this topic.
Good day, my name is Abdurrahim Abdulaziz. I am a student of Tashkent Textile and Light Industry Institute, Group 3R16. And today my presentation is about composite materials. What is a composite material? Composite material is a system materials of composite two or more macro consistence, and that differ shape and chemical composition which are insoluble in each other. Composite materials can be used in aerospace industry, metal alloying industry, sporting goods industry, in all industry where is materials. For example, in planes like Boeing, you can see, yes, Boeing, there is all is from composite materials. Here or here, everything is composite materials. Somewhere is it's from metal, and somewhere it's from ceramic, somewhere it's from polymer. What is a composite material? It has some phase, multi-phase metal, significant proportion of each phase. And composite metals can be made, as I said, from metal, ceramic, and polymer. And it's the classification of composite materials. Dispersed phase, you can see increase of classification. This is a metal, this is ceramic and polymer. And we can use also wood in composite materials. Some structural organizations of composite materials, it can be look like this, as you can see, from diagonal or other types. You can see the composite material structure. Composite materials can be composite from three ways: particle reinforced, fiber, or structural. As you can see, difference between. If we use particle, it will be a large particle, but not so ductile. Ductility will be low. But if you use fiber, it will be brittle. And so structural is between of ductility and brittle. You can see benefits of composite materials, which is made from metal and polymer, and its behavior. If we will high temperature, it will go up. As you see, it's displacement. So, and sort of particle one. It's a matrix and particle reinforced composite material. We use here ferrite, and so all of one says that it will be just metal. No, it has the name ferrite. So as you can see, ductility is here very low, but it has a very high brittle. It's the first method of reinforced. And this reinforced method we use in automobile and aerospace industries, but not in textile industries. In textile industry, we use fiber reinforced composite materials. I will show it next. Yes, this fiber reinforced composite materials, and there is a behavior of composite materials. And here's wolfram will be 100%. It will be a very high ductility, with very high ductility. And yes, fiber composite materials, they provide scientific strength improvement to material. So we use it in all spheres, like textile industry, light industry, other spheres of light industry. And also we have structural composite materials. As you can see, this is a matrix, so it means structural composite materials. We enter another material to structure of other material. It will be structural composite materials. If we use by chemical methods, it will be fiber reinforced composite materials. As you can see, behaviors of composite materials. If its ductility is very high, there will be behavior like that. If there is a brittle is high, the behavior of this will be like that. Fiber composite materials also made by graphite, cremini, and cobalt molybdenum, and it's extremely strong. And the strongest we know is graphite. Okay. Then fiber is also we can add to fiber composite materials polymers. Polymers like not only polymers, polycrystallines, also ceramics. Some ceramics you can also add. And from metals, steel, or wolfram and molybdenum. And this structure of fiber aligned continuous, as you can see, it's continuously. It will be continuously, not like that, not like random. It is a structural composite materials, and so that's why is the strongest will be very high. And difference between fiber and matrix composite materials. If we will add, continue to add, matrix will be in some way deformed, but fiber will not be. So we can, in aerospace or space industries, only use the or fiber or reinforced composite materials. And you can see a deformation, and it's the difference between first position or second position of fiber and matrix. Also, the transverse loading fibers carry loss of the load and are instead isoters. We know isoters is when modules are transverse. So we can use it in all industries. We can make our own composite materials. Not standard composite materials, we can make our own, which we need. And this is all for graphics of composite materials and how much we use strength to make some composite materials. As you can see, up to 2 and 4,000 megapascals. Also, strength, we can choose which strength or which length we should, and how we can deformate it. We all can use it in fiber reinforced composite materials. We can add some characters to our composite materials, so it will be not so valuable. And ductility of molybdenum and nickel. It's in the between of all composite materials. Ductility and brittlety is, I can say that the ductility and brittlety is over the less, so it's okay. And there's an example about carbon materials. So not only polymers, we can use the carbon materials, and from graphite, it's very less paid. So we all industries want to use carbon materials, and it's for payment is very okay. Thank you. And structural composite materials, we can make it there if we take 2 needles and place under them. It will be composite material. There is no chemical or temperatural methods. It's only putting up to there by mathematical method. It will be composite material. So we can use it in some structures where we don't have chemical methods or some temperatures. And there is a structural composite polymer matrix processes. Some processes, open phase molding and hand up, lay up, spray up. It is we have some matches here, but we don't have some other spraying or holding. Open mold presents only one mold male or female is needed and may be made of any material, such as wood, reinforced plastic, of round sheet metal, or electroformed nickel. We can use all materials, and we can make some composite materials if we need some. And shaping have two steps. First is mold release again. Second is unreinforced sunfresh layer. It means it will be deposited for best surface and best quality. And hand layup, the resin and fiber are placed manually. We use it in air to making planes, airplanes. So it will be better than other composite materials. So its process is very high with very high quality. And some spray up. As you can see, we have some material, and with spray gun we spray up another material, and will be a spray up method. It's also a structural method of composite materials. Type laying, we can cut and lay other materials onto them, and it will be also as another method of making composite materials. And you can see other methods, executing circumference winding, helical winding. It's all types of winding. So we have a circular some type of material, and we'll wind somehow with some method with helical or with polar winding, and it will be also composite material. This materials is used in gydrosphere industries. Okay, and this also characters of winding method, such as the filament, void volume, and other, and how much it will be cost. We can see here. Pultration, it's a bit difficult method. We should choose materials and also pull them into the circular cameras, and it will be at first heated, and then we need cooling camera. After that, we can cut and take our composite materials. It's some bit difficult method. And as you can see, it's a small diameter. Products are with small diameter, and it will be cost very high. So it's not so profitable for us. Other methods you can see fiber roundings or performing dye, coring dye. It's all methods of making composite materials, but it's not so used, so we will not see them. Okay. It's also one method. It's also difficult as before that. We need three or more materials to make one composite material, and it will be very high quality, but it will take a lot of time. Summary: composite materials are classified according to matrix materials, or if they reinforced with geometry, it means fibers or layers, particles. And their their properties are from matrix, as I said, metallic or ceramic or polymer, and we classify them according to elastic modulus or properties of isothermic. Isothermic properties. We classify them, and that's it. Thank you.
My name is Shakirova Saida, and I'm a student of Tashkent Textile Institute, Textile and Light Industry. So today's my theme is Nobel Prize. I think all of you have heard about Nobel Prize. It's very popular and well-known prize in the world, and I think every science wants to win this Nobel Prize. So now let's go in the past and to know about the history of the Nobel Prize. Nobel, he was a man. Alfred Nobel was born in Stockholm. After a few years, his family moved to St. Petersburg. Nobel hasn't accomplished any university, but he has educated by his private teachers. He learned chemistry in Paris and USA. He was fluent in Russian, English, German, and French. But firstly, his name was connected with the invention of dynamite, which was actively used in military industry in World War II. Thanks to this invention, he was being given a big amount of liquid. After his death, this is the will of Albert. He said, all of the possession that I has gained should be distributed as following: change my estate into gilt-edged securities, which would create the percentages fund as a prize to individuals who brought the benefit to humans' life during the year. So, who can win the Nobel Prize? Every year, the Nobel Prize is awarded to individuals following order. First, physics. Second, chemistry, medicine or psychology, literature, peace, and from 1969, economy also added. Here is the first owner of the Nobel Prize in economical sphere. Ragan Anton Kilton-Friedge and John Timbergen. They won the Nobel Prize in 1969 for creating and using dynamic model to analyze an economical process. So it's Richard Taylor who won the Nobel Prize last year in 2017. It's also in the sphere of economy. He is an American economist, winner of Nobel Prize for contributing to the behavioral economy. So the amount of the Nobel Prize, according to the information in 2017, the amount of the Nobel Prize has been increased up to 9 million Sweden crowns. It means $1.12 million. This decision was made by the head of the Nobel Prize. That's it. Thanks for your attention.